Alright, so we have another problem that involves changing into some kind of value here. Okay, so in this case it says scores for the California Peace Officer test are normally distributed. The mean is 50, so mu is 50, and the deviation is 10. Okay, so let's kind of draw a picture here. You have your bell curve 50 in the middle, and then we'd be going by tens to get standard deviation. It says an agency will only hire applicants with scores in the top 10%, so somewhere over here, let's say. Okay, the area is going to be 0.10 and its area to the right. What's the lowest score an applicant can earn and still be eligible to receive or to be hired by the agency? Okay, so we're going to have to use, we want to get a specific value here. We want to get a specific value, and you could do this, in fact you're going to have to do this using inverse norm, but you don't necessarily have to deal with z-scores here, and I'll show you why. So if you go to inverse norm, remember this number here is the area. This is for TI 83s. If you're on an 84, it's going to just give you a screen where it says, you know, area and then mu and then sigma. So that's area. This one is supposed to be mu, and this one is supposed to be sigma. Okay. So instead of putting 0 and 1 for sigma and mu, I want to get the score immediately. I don't want to have to get a z-score and then change it into an x score. So here's how you can do this. Instead of putting 0, because remember this is how it would work if we were using z-scores. I'm just going to put 50 here and 10 here, and then put area to the left right here. So if 10% is over here, 90 would be over here. So put that in, and you'll get a z-score. Sorry, not a z-score. You'll get a test score that you would need. It turns out to be 62.8. That's a little bit faster way of doing it than having to use this formula right here.